All right, well, let's get started. Welcome, everyone. Thanks so much for joining. We're here to talk about how to operationalize access policies across multiple clouds. My name is Jerry Gable. I'm the head of standards at Strata Identity. And Roger suggested that I do my own intro for you. So I've been at Strata now for a couple of years, working in this role. Prior to that, I worked at Axiomatics, which is a fine-grained authorization vendor. And prior to that, I worked with my good friend over here, Gary Rowe from Burton Group. And before that, was a practitioner at Chase Bank in New York. So that's sort of my history. I've been involved in different kinds of standards over the years, and I'm here to talk about a new one today. So we're talking about access policies and multi-clouds. Why multiple clouds? Well, according to Gartner, the vast majority of enterprises are utilizing 2 or more cloud platforms these days, many more than 2. And there's different reasons for that, right? Could be like the analytics on one versus the data services on another. Maybe a third has a certain cost profile for the resources you're using. You might have acquired different organizations that have already deployed in one cloud that's different from the primary one that your organization does. So there's all of the different kinds of reasons for that. You could work for a very large company that has very different lines of business that have very different technical requirements. So that's some of the reasons why we have the use of multiple clouds by many organizations. And when thinking about standards from the identity perspective, we have quite a few mature standards to work with. Things like SAML, the Security Assertion Markup Language, or more recently, OpenID Connect, or OIDC. So they help you integrate across different security domains and implement single sign-on and help with the authentication process. But what about after that step? What about access control to resources and data and network components after a user has authenticated? That's what we're here to focus on today. So I'll have a few slides. I don't have too many slides in this presentation. I have quite a bit of time devoted to demonstrating some of the things I'll introduce to you today. So hopefully you don't mind a smaller number of slides. So we're here to talk about IdentityQL or IDQL and Hexa. So IdentityQL is a standard format for access policies because what we're trying to do is standardize access policy across the stack, across cloud platforms, but even ultimately down through the stack, from the application, infrastructure, data, and even to the network layer. We have the same issue to address, and we're trying to promote or enable interoperability of access policies across these very divergent environments. Another way to look at this is from this graphic. So we focus on typically the 3 main cloud providers like Google Cloud Platform, Microsoft Azure, Amazon Web Services, and also things like Okta as an identity provider. And of course, within each of these platforms, they have their own proprietary way of encoding and enforcing policies. There are some standards in the access policy arena, Open Policy Agent maybe being the biggest de facto one, millions of downloads of that open source system. You have older technologies and proven technologies such as XACML, or Extensible Access Control Markup Language, and OASIS standard, but that's about it. They're not, and furthermore, they're not interoperable. So that's the challenge we're trying to address here. Can we deal with the complexity and the fragmentation of policy out there by introducing a new standard format to represent those access policies? And it's not just us at Strata that have thought this up and thought this was a good idea to explore. It's really come up in a lot of the customer conversations that we've had. And I picked out these 3 here. I think they're quite representative. So the first one, we want to have a common policy set that is independent of the target systems. So they don't want to be so tightly coupled to the target environments that they're utilizing. Or slightly different approach here is we want a single format for authoring access policies that can be distributed to the runtime decision and enforcement mechanisms. So they're looking for a central UI to author policies for all different kinds of applications and infrastructure, but then be able to distribute out to those runtimes. And that's precisely what the Hexa side of our project does. And then the last one here is similar to the first one in that there isn't a common way to express policy across all the systems we manage, and we feel that is a huge gap that needs to be addressed. So this is, I think, representative of some of the comments and opinions of folks out there that we have talked to. So that's why we came up with IDQL, Identity Query Language, and Hexa. So what are they? Well, IDQL is the format for defining an access policy. And this isn't an invention here. This is what's commonly been used to express policies in many formats for many years. But we wanted to define this as a declarative model, and it's a 5-tuple model here. So subject, action, object or resource, within a scope, and within a set of conditions. So the idea is that this is a common representation of access policies that are ultimately implemented at runtime in a target system like Google Cloud Platform, for example, or within an open policy agent-enabled application. And then the other side of this is Hexa. So Hexa is an open source project where we've created a set of software that can take this IDQL representation, connect to the target environments that we have integrations for, and do things like discover what resources and policies are associated with those resources on a given platform, translate that to the IDQL format, and now over time, if I'm connecting to multiple target systems, now I have quite a library or a catalog of IDQL policies. Now I can manage that access going forward from that kind of interface. Now when I want to activate a change, we go back through the Hexa software. It does a translation back to the target format and activates it into production. So this is the overview of the IDQL and the Hexa project so far today. And this is a little bit of a deeper dive into the architecture of the Hexa orchestration system itself. So on the left is some JSON code that's an IDQL example. And then in the middle here, we have the main REST API. So I'm going to show you in one of my demos a sample administrative user interface that connects to this REST API of the orchestrator. And then within that, you can see the 3 main functions I just mentioned: discover, get policies, set policies. And then there are these provider packages. So for each platform that's supported, we have a provider package that does the last mile of translation of the IDQL to the native or bespoke format. And then what's also interesting here is for the providers that we're connecting to, we are utilizing their publicly available APIs. Since we're in the world of APIs, and many of these cloud platforms have APIs for user management, configuration management, even some of them specifically for policy management. So that's what we're connecting to. We don't have to wait for the product managers of these cloud systems to adopt IDQL or Hexa. We can bring the standard to them. And this is quite different from, say, in the early 2000s when SAML, the Security Assertion Markup Language, first came to the industry. That was a time period where we did have to wait for identity providers and relying parties to adopt the standard before we had enough of a network effect to really make use of it. But today in the world of APIs, we can bring the standard to the platform. So I think that's pretty cool. That's pretty significant. So in these provider packages, up until now, we've been working at this software development for a little bit over a year. We have come up with 3 different ways to connect with target systems and create this integration and the translation or the mapping function. And one of them is through one of these direct API calls. So we can use that API call to map, say, a group or a role and attribute or definition with that use of that role or group within an IDQL policy. The second format is doing direct language translation. So we have mapping capability today where we can map IDQL and translate it into Google's Common Expression Language or into the new format introduced by Amazon, their CEDAR policy language. And then the third one here is also interesting in that with the Open Policy Agent model, they have the ability to ingest data in JSON format as part of the request evaluation. Well, we'll see a demo where we've built a bit of Rego code that directly interprets IDQL in JSON format. So in the case of OPA, you don't have to write Rego policies. You can just use IDQL policies natively. So that's what our research has shown up until now, that we have these 3 different approaches that we can utilize when building new integrations or new connectors. Hope all that makes sense so far, because I want to show you some demonstrations. So we're going to show each of these in action here. But before I do that, I want to give you a bit of a tour of the project. Let's see, I need to do this so I can see what I'm doing. Sorry about that. All right, so the Hexa Policy Orchestration Project is a cloud-native computing foundation, CNCF sandbox project. It has been since last summer, since July of last year. And for those of you that are not familiar with CNCF, that's the home of things like Open Policy Agent that I mentioned, but also Kubernetes. That's probably what they're best known for. So if you go to their sandbox page and scroll down a bit, there you'll see us. That's the Hexa project. And we've got this link to our project website. Tells you a little bit more about it, the history and so on. And if you're so moved, you can join up in the working group, and hopefully some of you will be inspired to do that by the end of today. So that's the CNCF page. Since we're in the CNCF, they're really big about promoting open source projects. So this is the GitHub repo for the project. It has 2 main repositories, the Policy Orchestrator, which is the Hexa orchestration module, and the Policy repo, which is where the IDQL spec is defined. So if you click into the Policy Orchestrator, since it is CNCF, again, they're all about open source, so this is available under the Apache 2.0 license. So you can look through here, look at the code. It's written in Go, excuse me. And one of the demos that I will show you, you can set that up yourself. The Open Policy Agent-based demo is actually running locally on my laptop. And in here, in the README, are the instructions for doing that. You just need Go, Docker, and Pack, which is all free software. And then there's instructions here, for downloading all the source code. It's super easy to set that up and compile it. And then what you'll end up with is a Docker setup here with services running on different ports. So the orchestrator, the admin, the demo, and so on. And that basically looks something like this. So that's super, super easy to set up. Let's see. I think that's enough of that. Let's go back to the slides for a second and talk about the first demo. All right, so the first demo is I'm going to use the Hexa admin UI, and I'm going to connect to a project called Canary Bank, a fictitious application that's running on GCP, on Google Cloud Platform. And I'll connect there and discover that the app exists and its policies. I'll pull them into the UI, and you'll see them show up as displayed in IDQL format. And then I'll make a change to that policy, and we'll save it, which will get retranslated back out to GCP format. And I'll sign into that demo application so you can see the effect of making that change to the policy. So this is the admin UI app that you will download as part of the demo package. And over here is the Canary Bank application itself. So you can see I'm logged in. I'm Jerry at strata.io. And we usually pick on the HR section of this portal to show access to 3 different regions. So Canary Bank operates in the US, the UK. Usually takes a moment to wake up. There it goes. And also to the EU. All right, great. So now when you want to connect to an environment from the Hexa admin UI, you select what platform you're connecting to. In this case, it's GCP. And then we tell you the format of the key file that you need so you're connecting to the right project. So I've got some of these files here on my laptop. This is the one we need for that demo. And we hit install. And you can see we connected right away to this GCP project, and it's the Canary Bank. Now, when we go to applications, we get more details. We see that there are 3 lines here, and they correspond to the 3 different regions that we saw in the demo application. Now, this middle one is for the UK region, and so when we click on it, we get even more detail. We can see it's running in a Kubernetes cluster. Here at the top, we have a display window that pulls apart the JSON and formats that for you. And then down below is the actual JSON. So this is in IDQL format, but it represents a Google policy for an application that's deployed behind the identity-aware proxy. So from here, I can enable the simple editor over here. Here we go. And what I'm going to do is take the strata.io domain out of this access list so that I no longer have access. And then I'll save that. And that save button now pushes it back out to GCP, and it's been translated back to the identity-aware proxy format. And that usually takes a few extra seconds to propagate out there. So this is when we talk and dance and waste a little bit of time here until the UK region gets updated. As long as the demo daemons are cooperating with me today. It always seems longer when you're in front of people waiting for it to happen. Now I'm beginning to wonder if I made the right change. Let's go back in there and look. Yeah, that looks right. Well, while we are waiting for that, I'll point out that even though we're on a single cloud platform, GCP, we're also using different technologies here. You know, in addition to Kubernetes, the one region is actually deployed using App Engine. So even here on one platform, we're using multiple technologies. Yay, it's starting to fail. There we go. Finally, we don't have access. All right, we'll declare that one a success and move on to the next one. We go back to my slides. All right. So the next one deals with Open Policy Agent. So here on my laptop in that Docker setup, I have an Open Policy Agent, an OPA server. I have an OPA bundle server, which is where it gets its configuration information and policies from. I've got that same admin UI application running. I've got a demo app called Hexa Industries. So that's what we'll be using here. So I'll connect to that bundle server, and then I'll display the IDQL policy that's in there. Again, I'll make a change to it, hit save. That'll rebuild the bundle, post it back out to that server. The OPA server will pick that up, and we'll see how that changes the capabilities within the demo app. Now, we can store those bundles on different platforms. For my demo, I do have it running locally here, but we also have integrations with Google Storage, S3, and GitHub as well. And GitLab is in our backlog to support. So that looks something like this. So on the left will be me in the admin experience, connecting to the OPA server and pulling in the policies and changing them. And then over on the right will be the demo application experience, where I'll be clicking through the navigation bar in the demo app. So let's go and take a look at that. All right, so here's Hexa Industries, another demo app. Again, this one comes with the download package. In this case, I'm logged in with the sales group. And the only access control here is on the navigation panels. The main screen doesn't really change a whole lot. So dashboard, yes, I have access. Sales, great news, same thing. Accounting, I also have access. Maybe that's a mistake, and we'll change that in a moment. And HR, no, I don't have access to the HR tab. Okay, super. We'll go back to our admin. I'll delete the Canary Bank just to keep that out of the way. Now I'm connecting to an OPA server, and as I said, this can be stored in different locations, and the format for what those files, those connection files should look like is listed here. So let me choose this one. Hit install. Great. We've connected to that OPA bundle server. Go back to applications and look at the details. And here you see that it does correspond to that left navigation panel. So the dashboard, the sales, the accounting, and the HR departments. And then down below is the IDQL and JSON format. So again, we'll edit that and scroll down to accounting, which is right here. And sure enough, there's the sales group. So we'll take that out, save it, and that rebuilds the bundle server. Remember, we're not translating in this example. The Rego code on the OPA server will directly interpret this IDQL JSON input. And the OPA server does poll much faster for changes. So we go to the dashboard, can still see that. Hit the sales tab, we can still see that as well, as we should. And with accounting, now we can no longer see the accounting tab. And HR also is the same. All right, we're 2 for 2 on the demos so far. Let's see if we can keep it going. All right, next up is integration with the new Amazon Verified Permissions product and their new Cedar policy language. Now, Verified Permissions is still in private preview, so it's not like you can go home and try this out today. But it should be GA soon. It was previously announced in December at their conference. So we worked pretty quickly to see if we could map IDQL to this brand new policy language. And we were pleasantly surprised at how quickly we could do that mapping. Now, it is not yet in the admin UI that I've been showing you. Up until now, we just have a command line interface that does the mapping. So this demo will look a little bit different. So I'm going to have a terminal window open, and I'll show you an IDQL policy. I have the mapper program. It'll convert it to Cedar. Then I'll do a copy and paste. So I'll copy that converted policy into the Cedar playground. So like some other authorization systems, Amazon made a playground available. And one of the demo apps they have is a photo sharing app. So we do a slight variation on the photo sharing scenario. So I'll paste that in there. We'll test it out. And then I'll take that updated Cedar, run it back through the mapper, and come up with a changed IDQL. So we'll do a full round trip in this particular demo. All right. So here's the terminal window. And let me just show you the playground quickly. So this is the Cedar playground, and we'll be pasting the policy right here in this blank area. All right, so this is my starting point. This is an IDQL policy. It's very simple. It says that members of the Vacation Photo Judges group can view pictures or photos in Alice's vacation album. Pretty basic policy. So let's put that through the mapper. And at the bottom here, you can see hexamapper minus T equals what target are we going for? It's AWS Cedar. The other format supported is Google Bind, or Google Common Expression Language. And then the input is the file that you see displayed on the screen here. So hit enter, and great, this comes back. This is now the same policy in Cedar format. Permit principal action resource. So we'll copy that, go over here to the playground, and paste it. And the first thing you can see is that it does some basic syntax checking. So if I erase the semicolon, it complains about that. Okay, so the syntax appears to be good. Down below here is a box where you can put entity data. So similar to Open Policy Agent or really any other authorization engine, it needs to know information about the data you're asking about. Like in our policy, well, who's in the group Vacation Photo Judge, or what are the actions I need to worry about? What are the resources? So within the playground, it has a way for you to input this. So we have users in here like Alice, and of course we have Bob, and we have Giuseppe, and we have information about what groups they're in, and further down we have information about resources, photo albums, and photos, and so on. And then over here on the right in the playground, there's a form fill where we can put in each of those categories, the subject, the action, and the resource. So in this case, we're asking, can Alice view this vacation photo? And so this is making a call to Amazon verified permissions in the cloud and asking it for a response. We hit evaluate, and we get authorization denied. Well, Alice is not a photo judge. She's the owner of the photo, but she shouldn't be judging it. But Bob is a photo judge, so let's put him in here. Evaluate, authorization is allowed. Perfect. But what about, I want to have somebody from the AV team add input on these photos, and that's Giuseppe. And see if he has access. No, he does not. Like I said, he's in the AV team right here. So what we'll do is we will update the policy by adding another permit clause. And we'll change vacation photo judges to AV team. Great, now we've got another policy for the verified permissions service to evaluate. We've not changed the input parameters here, so let's see. Great, now Giuseppe has access. Awesome. Let's go back to our terminal window here, and I've already copied that change text into this file, change cedar v2.txt. And I've added the -p command here to the Hexa mapper. That will convert it back to IDQL and display it on the screen here. Great, so let's take a look. We've got the original policy is still here. Photo judges can view photos in this album, but now the AVT team, or the AV team also has this access. Excellent. We're 3 for 3 on demos. So let's call that a win and get out of here before we do any damage. And back to the slides to wrap up. Okay, so what do we see here? Well, with the Hexa software, we're able to connect, via API directly to these target systems. It's a very flexible way to build integrations. We don't have to build connectors per se. We can just build these provider packages that can connect to the target system's APIs. What does this enable? Well, one thing is distributed policy management. So I can now manage multiple target systems with one format. And for example, I don't know how to write Rego code. I don't know how to configure Google's cloud platform. I don't know how, other than what you saw me do with Cedar, I don't know how to write Cedar policies per se. But I know how to use IDQL. I know how to use a tool like Hexa to manage those target systems. So that gives me tremendous leverage over a very distributed and varied environment. It also means I can treat this access policy as code now. I can make that part of my CI/CD pipeline. I can treat it as I would any other change control policy, change control process. And I have the opportunity now to break the vendor lock-in to that particular platform, similar to how on the identity side, using standards like SAML and OpenID Connect enable you flexibility, interoperability, and vendor independence. We think the combination of IDQL and Hexa offers similar promise here in the access policy realm. So I hope that's inspired you to think about this topic a little bit. Are you and your organization are you faced with these kind of challenges to manage access across these very different environments? And would you like to get involved with developing a standard? It's a unique kind of opportunity here. You were still at the very early stages of developing the IDQL standard and bringing it to the industry. What about contributing to open source? A lot of folks want to have that, as a badge of honor on their CV. Here's a project you can contribute to today. I didn't show the backlog, but that's also a public aspect of the repo. You can see what we're working on, and we often will label issues as a good first option to dig into. So take a look at that. There's many different ways that you can contribute. You can be very active, helping us write code, digging into different use cases, exploring different kinds of opportunities, or you can be more passive but still be a supporter or an observer of the project. So there's lots of different ways that you can participate. We have quite an interesting group across both enterprise companies as well as software vendors or even other standards organizations. So it's a really interesting project. I hope you'll think about joining us. And with that, I think we have some time for Q&A. We've got a couple mics here. We do want to record the session, so if you have a question, please come on up. While we're waiting for that, I will ask, if you can, complete the survey. Folks at the conference really like if you could do that. And I've also included some links here at the end for some of the sites that I did visit. So yes, I think we have a question over here.
I have a few questions.
Okay.
The first one is IDQL a standard now?
Well, it's part of the CNCF, the Cloud Native Computing Foundation. So I would call it more open source than a standard at the moment. So it's not like the IETF or OASIS or W3C. So that's its current status. We are contemplating when to go to an official standards group like that. But I think it's definitely in our future. Just the current state is it's open source.
Okay, and then the orchestrator, does it run in the cloud? Or does it run locally on your machine?
Well, at the moment, it's running locally on my machine, the demos that I've shown you. But you can run it pretty much anywhere. You can take that container and deploy it anywhere.
Okay, and then the last one was the API, the app registration you have to do in the various clouds. Looks like you're doing certificate-based access for that, right?
Yes.
Okay. Well, apparently, that connection has some high-level privileges associated with it. So how do you recommend locking that down? I know it's case by cloud, but what kind of permissions do you have to give the app in each cloud?
Well, obviously you need read access, you need to write access because you need to be able to update that. And we would recommend that you treat those secrets like you would for your other production environments or support environments, so using vaults and so on, whatever best practices you use with other software of that nature.
And the downloads are all on GitHub? You
Yes,
showed us.
are
you going to share those slides later?
Yeah, they get published by the conference. So
yeah, the links weren't on there in the agenda yet, so hopefully they will be. Okay.
Or if not, you can always reach out to me, Jerry at strata.io, Jerry with a G. And yeah, absolutely.
Thank you.
Thanks for asking. Any questions? Yes?
Hi, I have one question. So can we use this framework for any legacy applications like for PeopleSoft or SAP defined policies through this opened Hexa, and can we implement those legacy applications?
Yeah, the answer is theoretically yes. So if there is a published format, say from SAP or PeopleSoft, that we know is stable, then theoretically we can map that to IDQL. So that's one step. The second step, though, is how do we connect to that environment? I mean, if it's a data center on-premises app, then to the other gentleman's question, then the orchestrator has to run locally as well, because you likely can't connect to it over the internet. So that's the two aspects. Can we map it to and from the IDQL format, and then is there an API or a way that we can integrate with the platform? And we as a working group, we're not going to build every possible integration, but that might be something. If you're interested, you could join the community and work on that. We would provide you guidance. We would show you how we have built connections and integrations with other platforms, and using those three methods that I mentioned, and so we could collaborate to build connections with new environments.
Okay, so I do see actually the runtime policy changes and publishing. It's really fantastic. Can we automate this based on some AI or anything, learning the user's data and user's behavior?
Ah, interesting. We are exploring a bit of that at the moment, looking at large language models as a way to do policy translation. I don't know if that necessarily applies to your question about, can we monitor activity and determine what a policy should be, but we are looking at different avenues for how to make the policy discovery and translation easier.
Okay. Thank you so much. Nice presentation.
Thank you, appreciate it. Anyone else? If not, thank you so much. Really appreciate you joining me.